Well, thank you, few dedicated people, for joining me during lunch. Thanks, droidcon, calling you out on that. The guy who was keeping you from lunch, who am I? Well, I'm a seasoned pen tester working for NowSecure. NowSecure is a mobile application security company. What do? We test mobile apps all day, every day. A little bit different than some of the other folks you may have talked to around the booth floor. Their focus may be a little bit more on app protection. We're focused on ensuring that those apps remain protected by continuous testing and mobile application pen testing. I've been doing security engineering, app development. I've been doing penetration testing for over 20 years, a lot of that for the US federal government. I've focused on everything from mobile, medical, high threat environments, wireless cellular, you name it. I've probably had my hands in a little bit of everything. I'm also an avid security and privacy nut, so you'll get a little bit of that today. For the few of you here, I've got a couple quick questions. Raise your hand if you've had to spend some time remediating security issues. How about if you've had a release that's been blocked due to issues either in Google Play or by your own security team? All right, we got a couple there. Raise your hand if you have no idea what your security team actually does. Good to hear. And raise your hand if your app doesn't even have a security team. Oh, yeah. All right. This is the talk for you. Well, I'm here today to help you save some time and money, all while reducing risk. So let's talk about your app. Imagine your app is an automobile. I'm going to use a lot of metaphors today. You want proven tech, so as an automobile manufacturer, you bring in components from other manufacturers. Why reinvent the wheel, right? Somebody else has done it. I can pay them to bring in those parts. They integrate into my overall design. Guess what? By doing that, I save time. I didn't have to develop it myself. I saved money. I certainly didn't have to invest the research money into figuring out how to develop it. And finally, I saved a lot of effort by not having to do that myself. That concept, exactly equivalent to mobile SDKs or third-party code. So a recent review showed that more than 50% of a mobile app is third-party code. These components, and why I'm here today, if they're not evaluated, if they're not implemented properly, they seriously can pose privacy and security risks. And interestingly enough, if any of you all have come by the NowSecure booth upstairs, we polled a bunch of folks who came by with a quick survey. 20% of the attendees who stopped by said that the app that they're working on is made up of at least 50% open source code alone. So what are some of the concerns that we have to focus on? Well, number one, improper or incorrect implementations of that third-party code. So leaning back into the automobile metaphor, physical components, much like our software components, just don't drop into place and work. We have to configure them, right? We need to configure those. We need to understand the environment in which we're configuring them. So there's very specialized configuration that may take place. And in many cases, there's a lot of expertise that may be required in order to correctly implement those components. So let's imagine in this car, this automobile metaphor, that your ignition, the car ignition that you're integrating, let's say that that ignition has 3 wires, a red wire, a blue wire, and a green wire. Well, the ignition in my automobile, or the ignition system that I've developed, only has input for 2 wires. Okay, well, that's a problem already. Well, what if I just plug those 2 wires in? Well, the car started. Okay, so that seems to work. I'm probably okay, right? Well, maybe not. There may be unintended consequences. There may be issues down the road. Maybe there's battery issues. Maybe there's reliability issues. If you don't implement the components correctly, if you're not following a specific specification, then you may introduce errors or risk to either the platform or its users. Same situation with third-party code. So a real example, cryptography, favorite of mine. Randomness is important, okay? So randomness, key part of the cryptographic system. If we're not using random numbers, it makes it much easier for an attacker to guess an input and subsequent output. Poor random number generation is a common reason that we see compromising cryptographic libraries out there. And there are a lot of cryptographic libraries to choose from. Now we can scan for that, right? My company does that, other companies do that. There's open source static analysis, there's code review, but guess what? Context for that use, for that particular instantiation of using a random number generator, something like getRandom, right? That's not known by those scanners. So the context, is this being used in a security-centric context? Is this being used in a way that's protecting user data or something else that's sensitive in my application? That's not known by those scanners. And so they either surface everything, which means that a security team or you as developers are weeding through pages and pages of false positives, having to find the one bit of evidence that actually matters, or you filter it out and you miss something. So that's still a problem. Another example of an implementation mistake was several years ago, there was a highly publicized Firebase cloud messaging misconfiguration. And certain legacy keys, so there's a new version of the API key that's not a concern anymore, but the legacy key system that Firebase used was included in a lot of popular Android apps. And it actually, the discovery of this key allowed attackers the ability to push messages across the entire global user base. So if you were a Microsoft Teams user, if you were, I'm forgetting, I think there was several Google apps as well that were vulnerable to this, but it was a global issue that took place. And as you see here on the right, it took Reddit by storm as folks were starting to post about, hey, why am I getting these weird messages? Why? Because of a simple misconfiguration. A key that was seemingly benign was included in the application, was included in SDKs, and it was overlooked because it didn't seem to matter. It was an API key. It's supposed to be integrated into your application, but the wrong key was integrated, thus granting these administrative or these wide-reaching privileges. What else are we concerned about? Well, defective components, similar to implementing a properly designed component incorrectly. We're also concerned about components that are not designed correctly. Automotive manufacturers, they don't choose components by chance. They conduct extensive testing. There's regulatory requirements that they need to perform so many hours, so much rigidity around their testing. They even evaluate their supply chain. So they look at all of the materials that go into each component and how far back that goes. Where is the metal sourced from? Where is the rubber sourced from? How do all of those parts play into my component? Is there reliability? Is there enough material? All of these different things. Now imagine the damage that you might have to brand reputation if, for example, tires that are chosen and put on your automobile are ultimately defective, and ultimately they cause accidents. Well, of course, that's exactly what happened in the late 90s to Firestone tires, and specifically to the Ford automobile. So Ford suffered in the late 90s significant brand damage because not of their own design, but by the fact that they actually implemented a third-party component, these Firestone tires, that were ultimately defective in creating this problem. So Ford suffered for something that they did not ultimately design from the ground up. So we have a lot of choices here. We can choose open source, we can choose closed source, and for the record, I'm not advocating one or the other. Both have their benefits, but both have their downfalls. Open source SDKs, they offer significant cost savings. Frequently, but however, they may have issues that have yet to be resolved or prioritized. This is a common thing that we see during our testing, specifically our pen testing. We find that there are many projects that have been, these third-party projects that have been implemented in apps that are stale. I haven't seen updates or commits in 3, 4, even 5 years. You look at the issues that are in GitHub, GitLab, wherever the repository is, they're numerous. We've seen projects that have well over 3,000 issues, some of which include reference to Now Secure and some of our automated scanning, asking the developer to fix that. They go unfixed, they're deprioritized, or the project is just completely not maintained. We also have the concern around open source SDKs around unverified commits. So this is another concern of, well, do you really know who's committing code to this repository? What was their reason for committing that code? Was it altruistic, or did it have a more sinister purpose? There are recorded instances year over year of malicious actors working to commit malicious code into popular open source repositories. Now, on the closed source side, well, you don't have access to the source code. So how are you supposed to review the implementations of these SDKs? It can make it difficult to understand how they operate, and by way of how they operate, how to potentially secure it. So when selecting either SDK, it's really important to look at, well, what's the testability of this? How can I conduct continuous testing to make sure that I remain secure by using these SDKs? Now, in 2019, several companies found themselves on the receiving end of a really enticing offer from a company called Elephant Data. They had a really interesting offer. Hey, just throw in a couple lines of code into your app, you get $1,000 a month for every 100,000 users. Well, that's pretty good money. Okay, that sounds fine. You're just probably collecting some marketing data. Okay. Well, as it turns out, the SDK was silently loading and clicking on invisible ads. So it was creating a whole fraudulent ad click, ad revenue network. In many cases, it also generated additional charges on users' phone bills. So it racked up data charges. It added additional impact to the end user. Now, I was in a talk later yesterday, and somebody asked about, well, these apps, these components that are going into these apps, doesn't Google Play scan for these? Don't they catch it? Doesn't Google Play protect, prevent it? And yes, they do catch many. That part of their purpose, part of their program is to prevent malware from entering the Play ecosystem. They have lots of security checks and balances, but you have to remember how many apps exist in Google Play, millions upon millions of apps, and they have to balance security with usability, with accessibility. So if you lock it down too much from the get-go, if you prevent too many apps from getting into the ecosystem, then you see a lower adoption of that ecosystem. You see developers going around that secure implementation, and they go to third-party app stores. And so Google's point is, we'd like to catch as much as we can, but we can't push too much. We need to apply policy. We need to provide the developer with as much security relevant API access as we can without doing the scanning and preventing them from uploading to Play. And so that's a very tenuous balance there. What else are we concerned about? Well, regulatory and standards violations. This isn't a fun one to talk about. Policy, everybody's favorite thing to talk about. That's a great way to nod off during lunch. But it's really important. As Volkswagen found out in 2015, they installed software in their vehicles designed to cheat emissions testing. Ultimately, they got caught, and it resulted in billions of dollars in fines, as well as brand reputation impact. Use of components that violate industry standards can have, that immediate impact as well as long-lasting impact. So interestingly enough, the SDKs that you integrate may be subject to those same procedural or even legal actions and requirements, especially if you don't take that responsibility seriously. So policy is everyone's concern. Standards, regulations, regulatory requirements, everybody needs to be aware of. Everybody needs to take some time and read up on what is the latest even as it applies to something as simple as Google Play. So minor issues can impact even your app release. Something as App Store submissions getting rejected can have immediate financial implications for your company, for your app. So you want to get those apps released so that you can make money, so that you can get those out to your user base. But minor issues, minor policy violations can prevent that. So Google makes it very clear for SDK integrations, if you include an SDK in your app, you are responsible for ensuring that the third-party code do not cause harm to your users or violate Google Play's policy. So this is a complete paradigm shift from what we saw in the past, where SDK developers would be directly responsible. Now, Google has put the onus directly on the end app developers themselves. So there's a section within the Google Play Developer Console called the Data Safety section. It's been a new policy. It's been around for about a year and a half or so. You have to declare certain things about how you handle your users' data, handle and process. So any user data types that they specify that are collected and or shared. But what's really important to note is that any user data that you send off the user's device, and not just you, but any SDK that collects it, regardless of whether it's transmitted to you or a third party, must be declared. If it is not, and Google catches it, they can remove your app immediately from the store. This is something that we see very frequently. Google is very concerned about it. Now Secure actually works very closely with Google on specifically this concern. They want to know, how can we catch app developers who are improperly declaring how they're handling user data? Most importantly, most of the time, they don't even know they're improperly handling it. It's because third-party components are doing it improperly. So what do you do about it? Well, frequently identify the dependencies in your app. A common one that I hear about is the OWASP dependency check. I won't say it's the best tool out there to do it, but it's free. It's available, and it does a pretty good job of identifying the dependencies in your app, and it can do a cursory vulnerability search. So it's pulling known vulnerabilities, CVEs, if you're familiar with that term. It's pulling that information in, and it's a pretty good solution. There are a lot better commercial solutions out there, both pre-compile, post-compile. That's a great way to get started on thinking about keeping a catalog of what your dependencies are. More importantly, keep them up to date. Keep them up to date. I can't tell you how many times that we test an app where I see OpenSSL being used or has been integrated, and it's a library, it's a pre-compiled library. It's not something that, you know, is getting recompiled every time you compile your app. That pre-compiled native library, months out of date, sometimes years out of date. Well, if you look at the release notes in OpenSSL alone, the number of security bugs that they're fixing every single release are just overwhelming. So keep your dependencies up to date. Do your due diligence and testing before you integrate new SDKs. So when you identify an SDK that you are interested in, take the time to understand, well, what's the maintenance that happens on this? Is it open source? Well, how frequently are there new releases? Are they integrating new security fixes? Are they updating their dependencies as well? So often third-party code, they're like, hey, it works. I don't want to pull in anything new because it's going to break my SDK, which is going to break everybody else. Completely understandable. Right there with them, but make sure you do your due diligence testing before you integrate those. But don't stop there. Continue to engage with security testing vendors, your own internal security teams if you've got them, to perform continuous testing after you integrate those. And then finally, employ defense in depth techniques. Runtime application self-protection, or RASP technology, is a great way to add that extra layer of security. You know, we've got vendors, I see AppDome shirts here that have RASP technology that they're providing. There are other vendors out there that provide it. Take your time, take due diligence, and look into some of those technologies. They make my life as a pen tester that much harder. That's what you want. You want a diminishing return for an attacker to try to attack your app. Defense in depth is another great way. Make sure you understand how the SDKs that you integrate handle your user data. Again, you don't want to get caught in a Google Play rejection notice because you didn't define your data handling practices properly. And then show your users that you and your app cares about security and privacy. And with the remaining time, I think I've got about a minute. It's not a trophy, but it's a pretty cool badge. Google founded the App Defense Alliance. It's focused entirely on securing Google Play. One of the things that you can do is go through something called an independent security review. That badge right there will show up publicly on your Google Play listing. It is a differentiator in the market. It's fairly new. Google is rolling it out quietly to developers, but we're seeing more and more momentum pick up on this exact program. I encourage you to look more about that program. So a couple final thoughts. Do you know all the SDKs in your app? Are they up to date? What vulnerabilities do they introduce? Because 85% of the ones that we tested specifically for that App Defense Alliance project, 85% of those failed because of an integrated SDK and something that SDK did. So check out Google Play's index. They have an SDK index specifically geared towards known vetted SDKs. If an SDK developer has registered, you're going to find it up there. And specifically, this is important for you developers, data safety section guidance. They're going to tell you exactly how to fill out that form so you don't have to make mistakes. Right on time. Thank you, everyone. And I do have freebies because everybody loves freebies, so I'm going to change it a little bit. I know it says enter to win. Since you took the time to stay with me today and delay your lunch, if you come up here, I can give you a card. Any card that you bring by the Now Secure booth will grant your app a free evaluation for this independent security review. That's a several $1,000 value that I'd like to give you and your apps, something that'll be a market differentiator on the Play Store. So thank you for coming by. If you want to win a Lego set as well, go ahead and scan that. And if you have any other questions, come on up and talk to me, or come on up to the Now Secure booth right outside of Robertson and have a chat with us. Thank you all.